Okay, so I guess it's working right now, right? So I'm waiting for you, man. Yeah, I'm getting some feedback. Are you able to see my screen? Yeah, I'm good. How are you? My only viewer. I bet the sound is not so good, obviously, because of the MacBook mic. But tell me if the image is okay, please. Smooth. Okay. All right. Okay, so let's give it a shot. Um, I will do it in the desktop to make it easier. So, what are we gonna build with graphics? Basketball app, something like that. Will be a basic game. Just throw the ball. Um, yeah, doesn't matter, but I would like. So, um, thanks for the promotion in the channel, man. Um, this is like super improvised, so we don't know how it will go, and it has to be very quick because it's super late here. It's a test, basically. I will try to make a proper one later. And it's not cool to not have like live people. It's a good thing. So, pop spec, graphics, any. We start with the basics. Hope the streaming is okay. Usually I use the Mac OS Target because it's faster. It's easier for me to build it. I will make room for it. The Hello World app. So, what can we do here? Hi, Nico. This is so improvised. We will not. We will go straight to the graphics part. So this is the basic widget for any graphic scene builder widget, which takes a builder. It's a function. So we have the scene controller as the initial controller for two scenes. The back end of videos probably how they work, but we will do like a game right now, a very basic one. Still don't know how to, but we will try. So this is a basic setup for graphics, which extends from sprite. Okay. And we will override added to stage. We should do the same, nothing changes. We are not rendering anything here. So let's make a ball. Shape is pretty much like a sprite, but cannot have any children inside of it. You just draw things into the shape. It's like using the path in the canvas for custom painter directly. I'm sorry if I have some lag, man. Maybe later the video will be fine. So let's see how it goes. It's a test after all. So, a child. This is like a basic method for any sprite or any display object container. Right now, graphx, the only display object container that it has is the sprite. So you can add multiple childs into it. Right now, we have to add it. Otherwise, it will not render on screen. Like the basic core functionality of the shape and allow us to draw things into it. For most of the fields in graphics, we use hex colors. Okay, we don't use the color class directly yet. You can do something like this using using the material library. You can do something like this, and it will work if you want to use the pre-made material color palette. But I don't know. Otherwise, you just put the hexadecimal number there, and this is the same. This is like a shortcut for this. We will draw, which is a ball. We will use the 0, 0 coordinate in x and y. Okay. And we define a radius, which is half the width, basically. I will tweak the stream a little bit. And we'll see if I can do it. Because apparently it doesn't have a good resolution. Let me check how to. I don't know. I really don't know how to change this. No porn. Open, man. I don't know. If you have any hints. This is for OBS. Okay. I guess it's the output in OBS. Is that right? Should I use half of it? 100 right now. Kilobits per second. Let's do 1800. See how it goes. I don't know if it will change it live, but I don't know. I will keep doing the video, trying to wrapping up, and then we see how it goes. So anyway, we are in sync right now. We have 0, 0, 20, which is the X and Y position where we draw like a pencil. Then we have the 20, which is the radius of the circle, means half the circle. Anyway, we will end the field. This is not required, but it's good to have it most of the times. If you want to append multiple drawing commands, you should always end a field. This will place a ball right here because we put it in the scaffold. So this is actually the top left corner of the window should be the 0, 0 location for us. So there you go, a quarter of a ball. We can change the position of it. Move it 100 points, bottom right. Oh, X and Y are the Cartesian coordinates, so usually it starts from the top left all the way to the bottom, increasing in X to the right and Y for the bottom. Okay, so if you want to go up, you go negative 100. In this case, it will be outside the window. Anyway, so what do we want to build? And we need something to throw the ball at, or maybe we just throw the ball and do the basic physics of it. That might be fun and enough because it's kind of late here. So graphx has interaction. Okay, you can use the keyboard, the touch interaction with your phone or mouse in this case. Sorry, what we want to check right now is be able to grab the ball and move it around. Okay, so we have this signals is the name that we use here, but it's like events. some data as a parameter with the touch information. Okay, so we can print out the scene data, and we will see when we press the ball here, we will get stuff. Okay, but most of the times you don't need it, but for some reason you need like the velocity or some custom Dart UI stuff that you can get from the mouse touch interactions. You can read it from it. In our case, what we want to build is click to mark it in a active state, so we can start dragging it around, and that's about it. Let's start with that part. So I don't know, ball pressed equals true. Get a variable for it. And we want to track down when we release it. We will make use of the stage for this. Why? Let's flag it as false here. And by default, it detects the mouse interactions that in this case are limited to the bounding box of this object. You can check this property here, which is actually hidden, renders the bounding box of the objects that you are drawing into the stage. Now, the stage is all and is currently transparent. And we are overriding this method in order to access the stage, because if we draw everything inside the constructor of the scene, of this sprite class, it will work, but the stage will not be initialized just yet. Okay, so it will render in the next frame. Anyway, the stage allows us to capture if by any chance we drag it around and we drop it, right, in a place where this ball is locked. Let's say we limit the position of the ball and the mouse goes over another area, and the ball will not detect anymore the hit test from the touch or the mouse interaction. That's why we have to listen on the stage, and it's like a safe way in order to get the event of releasing the touch from the screen or the left click of the mouse, you know. So anyway, we have two flags here, and this is an optional way to do a print that graphx has, you know, because you can add more parameters into it and it will print right here. It's like a shortcut. Oh, this is awesome. My mouse is dead right now. Cool. So press, we release, we press, we release. See how we get a release event even when it's outside the ball. Even if I click here, I will not get any press, obviously. It's not touching the ball, but it will work for the release, thanks to adding it to the stage. So we will use, there are two ways in order to capture the ticker inside the graphics. The first one is using on enter frame. This is taken from Flash in the stage. It only works on the stage. And you can add a callback into it. Let's say, and it takes a delta time. This is basically the time that passed from previous frame. Okay, so the ticker is rendering 60 frames the target value. So it should be, as you see here, around 60 seconds. If you do 1 second divided by 60, you will get 16. So that means we are not dropping frames. We create motion based on the amount of frames you have, but in our case, it doesn't matter. So do not pay attention to that parameter. You just need to know that this runs 60 frames per second. If you want to do some collision detection, transition, movement, twin, something like that, you can make use of the update or on the frame callback in order to do so. So we will check, first of all, if the ball is pressed. That means we want to drag it around what coordinate are we is the current touch position of the mouse right now. We can read from this class the mouse X position. This will store basically the current position of the mouse transformed into the current object. In this case, oops, we can see. You will see here when we press it and this moving, following our mouse, okay? We drop it, obviously it will drop because it doesn't fit inside this if part. But we can also check the mouse position inside the ball. So you will see how the current ball mouse position, you will see it's kind of different because right now we are positioning the ball into the mouse. So it's always like 0, doesn't matter where we move it. But you can get relative positions for the mouse or the touch inside the nested sprites. We will see that later. Move it around, when we drop it, we want to track down the velocity of our movement. How do we do that? With plain math, we can create two variables, which stands for velocity x and y. And in order to track it down, we have to record the previous location of our ball, meaning from one frame to the other in those 16 milliseconds, what is the difference in distance between the previous frame and the current frame for the position of the ball. So we will need alt X, alt Y, okay? So when we press it, we store the ball location there. Now we need to track down velocity. Which will be the difference in the current position and the old position. How it goes. Oh, every time you want to refresh something, hot reload is not enough. We are not in the widget world, so we have to hot restart the scene, okay? So we have to provide some numbers for it. If I move slowly, we get a very small number. If I move it faster, we get higher numbers. So I guess it can work. The proper way to do it will be like storing a list of velocities from previous frames and make an average out of it. I think that's how the flicking thing works with scroll controller in Flutter. But in our case, we just make it simple. Okay, let's see if we can make it work. So if the ball is pressed, we are capturing the velocity. Instead of doing an else, I will do a return here. It's faster for me. At least I like the formatting. So otherwise, the mouse location to the ball location. See, we are moving the ball according to the speed we drop it in the last frame. Oh, well, all the way down. So we are getting some sort of physics right here, and it's nice. But we need several things. First of all, we need boundaries. We need the walls. We need the ball bouncing around or something like that. And we also need some friction. So we will do it the easy way, This will generate a friction every frame. It will drop the value by 90%. So it will make like a very smooth friction between frames. See how it works. Oops, I'm sorry. Or maybe I need a higher number. Oh, but I actually, yeah, doing it properly. What did I do wrong? Because I know my mouse right now is kind of difficult. I'm using the trackpad to double. Oh, I'm sorry. Here is new. We always should initialize our variables. This is running every time, so yeah, expected. We will create a friction now for the velocity. Oh, it's slowing down. Nice. Well, too much. Drop it off a little bit. Um, so we have the friction. Now we need the boundaries for it, right? Now it's more friction. Kind of like so far. You're following? We're good? Somebody there still? Too boring, maybe? Okay, I will keep going. So we just checked bounds with basic math. That's about. We check for x and y for the minimum and maximum positions. Um, how do we access the current scene size? We have the stage. So well, this is actually the proper way of doing it. It's the other way around. So if it's bigger, make it stick to it. We are having a ball, so the center is at the very center of the ball, not the top left corner. Otherwise, if it's less than 0, we will make it stick to 0. And the same for the y-axis. There we go. So we are dropping it. Okay, it's getting stick to the sides, as you see. Yeah. Okay, the walls are working. We get no bouncing, and the location is kind of off. We need to reduce a little bit the. Well, we need to consider the radius, the size of the object, because right now the 0, 0 is right in the center of the circle. So we will get the radius. We can hardcode it. Same, I think we use 20. Yeah. So if it's bigger than this, otherwise, if it's less than radius, it will be radius. Let's check if I didn't do it the other way around. So I drag it and I drop it, and it hits right on the edge. Same for the other side, so we nail it on that one. The same applies here. So we add the radius into the mix. Okay. So let's make it bounce. Bounce, that's the word for it. How do we make it bounce? Well, let me think. Every time we hit a wall, we need to invert the velocity in the direction we are throwing it, right? So it will be a matter of inverting the velocity. This will toggle the value between positive and negative. And that's what we want. For x, it's going in a positive direction, and it hits the wall, we will invert it to the same velocity in the opposite direction. This is for Vy. So let's see if we have some bouncing. Yeah, we do. Looks like a ball, right? I love it. Um, it's 1 a.m. and this is like a test, so I think it's kind of enough for this demo. What do you think, man? Can it work? This was all improvised, so I don't know. Um, yeah, I think it's fine. Maybe later we can actually finish the game in another video. We can add gravity into it, right? Y equals, how much can it be? 3. So every time we're not pressing the ball, we can append the gravity into the ball. Yeah, that should make the trick, dude, because the boundaries are already running. Very easy fix to have gravity, right? I love it. It's pretty easy. We can, but as you see, not many lines of code, and this is basically graphics. I just hope you like it. And this is a test. We'll try to make a proper one later. So have a good one, and see you next time.